All right, so upcoming next class is our test. Ignore the Tuesday, this is from an old set of notes. But the first topic that we covered here was frequency distributions representing our data. So we talked about frequency distributions, histograms, stem and leaf plot, and that frequency polygon where we connect the pieces of the histogram together. So if you go over to your course binder, which again, you can find the link for it right on my math lab under assignments. We're in chapter 12, statistics, and then there's a link there for your sample test. And the sample test will give you a pretty good feeling of how the kind of questions will be phrased and written on your test. Different numbers, but the same kind of problems. So you can see here in this first problem, we're asked to put together a frequency distribution. We're then asked to construct a histogram. In this problem, we weren't asked for the frequency polygon, although you could be. And then here we're asked for a stem and leaf plot for the swimmers. And then here we were dealing with a grouped frequency distribution. And again, along with the test is a sample test key where I worked out the problems. Now in this frequency distribution, I went ahead and did the percentages, although you weren't asked to do that in most of your homework, so you don't need to do that. Just the data values and the frequencies is sufficient. And then our histogram for that frequency distribution. You can see the work there for the stem and leaf plot. I know in the homework they made you put those numbers in order. I'm not worried about you sorting them into order for the stem and leaf plot, just as long as you have them correctly and have that sideways histogram. And likewise, the same thing here with our, there's our frequency distribution for that data. Again, I gave you the fractional amounts, but you don't need to include that, as our textbook didn't really emphasize that. And so that's 12.1. Again, you have the answer key there so you can compare your work. Look back to our notes, which you can find in the course binder as well. The next thing we did is we talked about averages, mean, median, mode, and mid-range. Okay, now the mid-range, when I put this test was a test from a few semesters ago. So it actually doesn't have a mid-range question on it, but that is going to be on your test. So you don't have questions about the mid-range on the sample test, but that is something that is on your tests. Mid-range, you average the high and low. So if you come over here, you can see here we're asking mean, median, mode. You'll also be asked to do the mid-range. Okay, same thing here. You have a frequency distribution. You're asked the mean, median, and mode. And you'll probably also be asked the mid-range as well on that one. And you can again see the work in the sample tests for these. You are only asked mean, median, and mode on the sample test. You will also be asked about the mid-range, but you can go back and check in the notes for section 12.2 where we did some examples on mid-range. They're pretty straightforward. So that is on your test. It's just not on the sample test. Be very careful not to confuse the mid-range with the range. Range is the spread of the data. That's where we see how spread out our data is by just taking the high value minus the low. You will be asked to do a standard deviation. Standard deviation. So there's a chart process that we set up, and I'll point that out to you again on the sample test here in a moment. So as we scroll on, there's a simple question. Go back to the data from problem number 4. So that was this data up here, and we want to find the range. So we would just be taking the high value 10 minus the low value 2, so that would have a range of 8. All right, and then we're asked to compute the standard deviation for this set of data. And so on the very last page of your test are the steps for standard deviation. All right, we first find the mean, add them all up, divide by the total. We then take each data value minus the mean. We then square those answers. We add them all up. We then divide by n minus 1, so 1 less than the number of values we have, and then we apply a square root. So again, you can see that here on our sample test, the standard deviation. All right, in this example, the mean was 5. So we subtract each data value from 5 from each data value. We squared them all. In this problem, there were 10 data values, so once we have that answer, we divide by 1 less than that, which is 9, and then take the square root, usually rounded into 2 decimal places. So that's what I'm going to be looking for with the standard deviation. Again, those steps are on the last page of the test. You just need to be able to follow them. Okay. We then talked about z-scores, which really comes up through the rest of the test. So in 12.4, we talked about computing z-scores to find the relative position of data items. So again, if you continue down here you're asked to compute z-scores for some different data values. In this particular case, we have a mean of 80, a standard deviation of 10, and we're just asked to compute the z-scores for 60, for 95, and for 35. Remember the process for computing z-scores. We take the data value minus the mean, and then divide by the standard deviation. Okay, we don't need to go any further with these ones. We're only doing the z-scores here. The last thing we did is we looked at using the normal distribution, percent above or below or between. And you can see here on the sample test, that's the question here. And the chart, of course, that you need for the z-scores, the percentages is there. Remember, the chart always tells you the percent below that level. And so here, this example happened to be the SAT test, similar to one that we did in class. We're finding data values between different things. So here it was between 500 and 600, below 570, above 460. Again, you can go into the sample tests and see those worked out. So for between, we compute z-score for each one, look it up in the chart, take their difference. For below, we compute the z-score, and then just take the value from the chart. If it's above, we compute the z-score, get the value out of the chart, and subtract it from 100. Now there's one other topic that's on your test that wasn't on this sample test, and that were these margin of error questions. Right, it's not on the sample, but it is a part of your test. And so you can go back to the notes. And if you scroll down here on the notes, we talked about margin of error. So here we had margin of error. That's 1 divided by the square root of the number of things you have. Right, that's our margin of error. Okay, and so we looked at a couple of surveys where we computed the margin of error. And we also used the margin of error to figure out the range on each person. All right, so in this case for Greetons, they had a 31% in the survey. Margin of error is 3.12%, meaning they could be that much above that 31% or that much below. And likewise, Smith was 23%. So they could be as much as 3.12% above or 3.12% below. And then we talked about margin of error on this other example with this survey for Monmouth University up in Pennsylvania. Surveyed 502 people, come up with these different numbers. And here we found the range of values for Biden, anywhere from 45 to 54%. In that particular example, that was from the previous presidential election. We also talked about deceptive statistics. That's not directly on your test. You have that on some homework questions. So that's all that we'll be doing with the deceptive statistics. I just want you to be aware of that mostly rather than testing you directly on that. Okay, so that is your test in a nutshell, which again will be in our next class. If you do have other additional questions, please email me, but definitely check out the sample test. Again, there's pretty much everything that we covered except for the mid-range and this margin of error. But just refer back to the notes or some of your homework problems on margin of error. Other than that, again, if you have questions, please email me so I can try to help you out. Otherwise, good luck, and we'll see you on test day.